Okay, so today I'm going to show you some tricks.
Whoa, I love tricks. I like skateboarding. What?
Okay, so sometimes our integral needs a little tweak in order for us to be able to use a rule or use some sort of technique that we have, like a use substitution kind of thing. Okay, so use substitution isn't going to work on this y. The derivative of e to the x is e to the x. So don't write this down. But if we had e to the x over 1 plus e to the x dx, would this be something we could? Yes. Could we do use substitution on this? Okay.
I thought you're supposed to do always like the inside of e though as u.
Not always. Because here we could use our denominator, right? 1 plus e to the x would be our u. So our du would be e to the x dx.
Yeah.
Okay? So it's not always, but that's what you've seen most often, right? Okay. So it'd be really cool to have e to the x in the numerator is what you're telling me. Okay. So let's put e to the x in the numerator. Now, it is not okay for me to just throw a plus e to the x. E to the x, right?
Right.
So if I add something, I would have to subtract. I have to add 0. I have to multiply by 1. So here I'm adding 0 in the numerator by adding e to the x and subtracting e to the x simultaneously. Yeah? Okay. Well, what's the benefit here?
Whoa, that's cool.
We can split it up, yeah. We can split it up into 1 plus e to the x over 1 plus e to the x minus e to the x over 1 plus e to the x dx. Well, cool. What's 1 plus e to the x over 1 plus e to the x?
That's 1. Hi, Nick.
And
Benjamin.
so now we have kind of our ultimate u substitution integral here. We have 1 plus e to the x could equal u, which means du is e to the x dx, and we have a perfect just 1 over u du for our integral. Okay, so now antiderivative of x. Antiderivative of 1. That's the second time I've given the answer in my question instead of asking my question today. Minus 1 over u's antiderivative would be I guess technically I wouldn't need the absolute value because e to the
That's all I
There you go. 1 plus e to the x is always positive. Okay. So, what other kind of tricks do we have in our back pocket? Multiplying by 1, okay? So here I have a list, okay? We just expanded the numerator to help us out, okay? we could have, well, and we also separated our fractions, right? You might have a fraction that you may want to separate into this fraction plus this fraction, and maybe that would help you a little bit. We have some rules that we talked about yesterday that rely on us to have perfect squares underneath, right? A squared plus u squared, a squared minus u squared. So it could be in our benefit to complete the square to force those arctangent or arcsine rules to occur. Okay. Yesterday we talked about dividing improper fractions. We have trig identities that we love. And we'll talk about when we have those trig identities, or we could have them, multiplying by a Pythagorean conjugate. Whew. Okay, so some of these we looked at yesterday, some of them we'll look at today. Okay, and then tomorrow we will get into integration by parts. Okay, favorite integration strategy of all time. Okay, so let's see. I think we have 4 examples to do. Okay. We're in here till 43, correct?
Yes, ma'am.
Okay. First one. After you write it down, have a discussion at your pod. Which strategy that we listed would be helpful here?
Why divide x squared by x over y?
You could, yeah. But do we want to do that? Is the question.
Well, if you
I
did
really
that,
don't want to do that.
if you did that, you would have.
You'd have a split up.
Yeah.
That makes sense. I just don't want to do that.
What don't you want to do?
Divide them.
Well, why not?
That's a lot of work.
Is it?
It's honestly
Yes.
not for that.
I mean,
is
isn't
it?
Okay,
it like
so
a
It would just
shortcut?
be
Chris
x plus 1.
and Caleb are arguing.
Isn't it like
about-
a shortcut? Like it's like use -1 or something like that. When it's, I just
Well,
remember
you
this little
could-
like square box and then you do like the numbers.
Synthetic division?
Yeah.
I mean, you could do synthetic division. Yes.
Could we not?
You're the one who said to do it in the first place.
I could do regular division.
Oh. Okay.
Since this is a improper fraction, you are right. We could divide. X times x squared is? X times what is x squared?
X.
It's alright. Happens to the best of us.
And then it would be -1.
Wait, where'd the x come from? The x squared plus x come from? Oh, you moved the.
We multiply these
Oh, okay.
and subtract. So then -1 times x would give us the negative x. And since we're subtracting, our remainder is 1. Anthony?
That's what Anthony said. Well, it did the same thing as what you said.
So we have the integral of x plus 1 plus 1 over x minus 1 dx. Okay, now what Anthony was saying is, hey, we can make a difference of squares. Okay. Anthony's way. In order to make the difference of squares, you would have to say minus 1 plus 1 upstairs, correct?
What?
And then we could split it, right? 1 plus x plus 1 here, and then x squared plus 1 minus 1 over x plus 1 here.
Oh, then it's x plus 1 times x minus 1. Okay. Wait, does that give you the same value? Yeah.
I copied it down wrong over here. Sorry, Nick. Sorry, Benjamin.
And wouldn't that make it 1 over x plus 1?
Oh, because I got, you know what I did? I,
Switch
bloop,
those.
bloop, bloop.
Okay,
Yep.
I was gonna ask that. I just wasn't sure.
Yep. I looked at the wrong, they were too close to the same to where I just grabbed the wrong one for each. Okay, so we're left with x minus 1 when we factor and cancel plus 1 over x plus 1. Sorry. Okay. Well, isn't it wonderful that we had two different methods discussed in our pods? I heard you guys kind of talking about, I know you talked about this one. I don't know if you talked about the division one at all. But isn't it nice to have two different ways to do a problem?
Oh, that's great.
No? Richard, what's our antiderivative? Oh, you're writing both methods down? Such a good student.
Derivative 1. On the what?
What's the antiderivative?
1/2 x squared minus x plus the natural log of absolute value x plus
Good. You get to the right answer either way. That was what? Confusing?
No, I thought that was cool.
It's okay to think it's cool. You don't have to hide that. All right. Next, look at your list of strategies I gave you. There's only one right answer.
Okay. I would have to go with trig identities.
What trig identity would you use?
No clue. I'd go with that.
That's like goes something.
Cosine
Well,
minus
no.
1 something.
Isn't like that's equal to 0 or something like that with limits.
Just
So
Is this a limit?
isn't sine squared plus
Technically,
cosine
aren't-
squared equals 1?
Sine squared plus cosine squared does indeed equal 1.
That's a cosine, not a cosine squared.
Oh, that is a problem.
So
A problem that we could fix. By, look at your list.
So couldn't you multiply it by numerator and denominator?
Say a letter.
did you just square it?
The Pythagorean conjugate. What's the conjugate of cosine theta minus 1?
Plus.
Oh, that's what those are called?
Yeah.
He said, "Oh wait, what?"
I didn't know that that's what they were called, but that's what I was trying to say.
Okay. I believe you. So what is our denominator when we multiply conjugates?
Cosine squared theta. Is it minus 1?
Yes. We get the difference of squares when we multiply conjugates together. A squared minus b squared. Okay. Now, what was that identity you spouted off? sine
Wait, can't
squared.
you, at this point, can't you just do u substitution?
Wouldn't it be, wouldn't the new denominator go
No.
to negative
What's the
sine
derivative
squared?
of cosine squared?
I don't know.
Neg-
Wait, the derivative. Never mind.
Okay,
I was thinking like
if
the
you
whole
want-
thing was squared, because then I was like, you could do like the inside as u, and then like that would be the same thing as the top.
Because the derivative of cosine is sine. So if you're going to do u substitution with a cosine, there better be a sign involved. Excuse me, negative sign.
Oh, a
But
negative
we can work with the negative. But
Never mind.
okay, so cosine squared
It's gonna be
minus 1 is the same as what?
Negative sine.
Negative sine squared. So what we have, because I
One
mean,
over sine
Now u
plus
substitution.
1 over sine squared.
it's not quite time for u substitution time.
Couldn't
You would be like.
Couldn't
It
you
would be
do u substitution?
Cosine.
Cotangent
2 times cosine.
Which is good, right?
Yes.
I see
You're not?
it now.
Okay. If I take cosine over sine squared,
Yeah.
negative,
Yep.
it would be negative cosine over sine is cotangent,
Yep.
but we have an extra sign in the denominator, so it comes up to a cosecant.
Oh.
Minus 1 over sine squared is the same thing as I love tree identities. What's the antiderivative of cosecant cotangent?
Cosecant
Square.
No, just
Just
secant.
cosine.
And the
Negative
antiderivative
cosine.
of negative cosecant
That's
squared.
cotangent squared. Nope,
Still
regular.
not. We're antiderivatives. Antiderivatives. Maybe we need a rule quiz.
Can you use my notes because I have all of them on one page.
Thoughts on that problem?
There's 3 terms, they all start with C.
That is a thought. Yes. Any questions? Clarification. Irrelevant. It's not-
Don't even do the homework.
Example number 3.
You know, this is going a lot more smoothly than I thought it would. I'm gonna be honest here.
Good.
Squared dx.
Talk about it at your pod.
Yo, kill. No,
Can't you just like factor out the x?
I mean,
And
you
then
can factor
do
out the
the
x.
substitution with the x, like
Like take
6 minus x, and then just substitute in for the x that you factored out.
That would just be x. That would just be x times u. That would
do
just
one of
turn
these
out
things.
You're still going to get a quadratic underneath in terms of u.
Yeah, that's what I'm
If you
saying.
do that,
So what if you say u is 6 minus x?
then you're still going to get a quadratic in terms of u when you do
Oh,
that.
'cause you have to multiply
Yeah, 'cause
out.
you have x times u,
Nice.
and then when you're literally going to use x section, you put in terms of u.
Wait, can we change this x to x to the 1/2?
Here's your hint. How do we force?
Not there.
Put 3 over.
Well, putting the 3 out front is one step.
Do some U's.
Thank you. What else will we have to do?
Do some U's.
How do I get this to be a number squared minus something with x squared? Look at your list. I'm saying square a lot.
Complete.
Complete the square.
Yep.
Every time it comes to every meter.
You don't remember how to do that? Let me remind you. Okay. We call it pre-calculus for a reason. I will remind you what we learned in pre-calculus.
Remember how long the calculus was?
Okay. So this is negative x squared plus 6x. Right?
Yes.
Okay. In order to complete the square, we must have a leading coefficient. That is 1. And so we are going to need to factor out the negative so we can complete the square.
Oh yeah.
Okay. What number would create a perfect square trinomial?
9.
As a reminder, we take b over 2 squared.
Wait a second. Is what we're going to subtract going to be under the radical?
Yep. It
Wait.
just doesn't really look like that.
Also write it bigger, but
So we subtract.
take a nickel.
Wait a second.
Are we subtracting 9?
And add the.
We're subtracting negative 9 because this 9 is being multiplied to this negative here.
Correct.
Okay? So what we have is the integral of 3 over the square root. I'm going to go ahead and reorder this. Are we all okay that that's going to be a positive 9
Yeah.
minus our perfect square?
Very cool.
Now we have our arc sine rule. And if we let u equal x minus 3, then du is just dx. Are we all okay with that?
Yeah.
So really, I mean, I'm not going to go through the u substitution because we don't have to account for any of the chain rule action, right?
Yeah.
So our antiderivative, let's see, arc sine only has one a, so we don't have to worry about the 1 over a. We just need to know the u over a. Let's see.
Hey, that's what I got.
This is a book.
Those grooves, my dude.
This 3 came from that coefficient times our arc sine rule of u over a. Okay? You will have to complete the square in your homework. Do you have a question about completing the square? If you get to your homework tonight and you're like, I forgot, you could always come back and reference this video, okay, and recall how we got the numbers here.
Hi, Caleb.
Completing,
You think you're gonna need it?
completing the
I'll do
square under a square root is just whack. Oh,
Set it up. Don't work it out, just set it up.
The 1 over 3 minus.
Yes, Caleb. 1 over 3 minus 1 times the integral from 1 to 3 of our function. You have an idea or a question?
I do.
Hold on. Look at it. Think about it. Chris, what's your idea?
You use 1 over t as u, and you get negative e to the u du.
Okay,
You're gonna get
if u is 1 over t,
1 over t.
du is negative t to the negative second
Yeah.
dt,
There.
which is there.
But it's still a negative, so you have to make it a negative 1/2.
Okay, so yes, you're right. We have to account for that negative 1/2 integral from 1 to 3 of e to the u du.
You always get these problems to be so perfect.
Kind of have to think backwards a little bit, right?
If I was a teacher, I would just give them a problem. If it doesn't work out, and be like, oh well.
One way to do it.
Surprise with me.
So our antiderivative is e to the u. And then we evaluate from 1 to 3.
The T.
I'm not sure what happened to my marker, but that is a t. Indeed. So we would have what? Negative 1/2 times the quantity, e to the 1/3 minus e to the 1st. And without a calculator, that's all the farther we're going to go. Right?
Can't you do like
No.
negative e
No.
to the 2/3? Because it's
No.
e to the 3/3.
Only when we're multiplying or dividing can you combine those. Oh, my goodness. Okay. We're done just in time. Look at that. Please.
Bye, Benjamin.
Please do your homework. Please attempt your homework. Each problem before seeing how CalcChat did it. They're really good at it.
That part is not a sport.
Don't forget Caleb. Caleb said he was going to come back to this.
Well, you didn't keep